Today's lecture is a bit technical and its name is hydrostatic force. So in this lecture we will cover two types of uh, hydrostatic forces. One is hydrostatic force on the plane surface and the second is hydrostatic force on the curved surface. So what we are doing is we are calculating the forces which are acted on the plane surface by due to the water. So at the bottom of the tank, the total pressure is equal to rho g h. And if we calculate the forces, so in order to calculate the forces, we need to multiply the pressure with the area. So the first part of the lecture is to calculate the hydrostatic force on the plane surface. So as you can see, this is an arbitrary plate and you have to calculate the resultant force which is acting on this plate. So in order to find the resultant force, you need to know these three formulas. YR is the location of the resultant force in the y direction and XR is the resultant of location of resultant force. So the resultant force is acting at point CP and C is the centroid of this arbitrary plane. So this is the standard chart which can be used to find the centroid and which can be used to find the moment second moment of area which is IXC, IYC, IXYC and for different shapes. So if you want to find the centroid of this semicircular, it is equal to 4r by 3 pi. And if you want to calculate the centroid of a rectangle, it is equal to a divided by 2. And similarly, if you want to calculate the centroid of the half circle, half semicircle, it is equal to 4r by 3 pi. And if you want to calculate the second moment of area, it is equal to 1 by 12 ba cube for a rectangle. Similarly, you can calculate for other. So in light of the three formulas I explained earlier, we have to find the hydrostatic force which is acting on this circular gate due to this water. So we are moving towards our first problem, and the problem says the 4-meter diameter circular gate as shown in figure is located in the inclined wall of the large reservoir containing water. The gate is mounted on the shaft along its horizontal diameter. For a water depth of 10 meter above the shaft, determine the magnitude and the location of the resultant force exerted on the gate by the water. The moment that would have to be applied to the shaft to open the gate. Moving towards the solution of this numerical, just remember you need to know the three formulas for finding the resultant force on the plane surface. The first formula is Fr is equal to gamma hc area, and you can find the location of the resultant force which is xr and yr. So Fr is equal to gamma times hc into area. Gamma is equal to is the specific gravity and it is equal to density times into gravity. So 9.8 into multiplied by 1000 is equal to gamma. You can find the HC, which is the location of the centroid, which is the height to the centroid of the plate, and A is the area of the circular plate. So you can see the height of centroid is equal to 10 meter, and in order to find the area of the circular plate, it is equal to pi r square. So pi multiplied by r is equal to 2 meters, which is equal to the area is equal to 4 pi. So the second part of the problem is we have to find the location of the resultant force. So we have to use these two formulas to find the location of the resultant force. So we find the location of the resultant force in the x direction, and it is equal to Ixyc divided by yc in multiplied by area plus xc. Ixyc is the moment of area in the xy direction, and it is equal to 0. So this term will be equal to 0, and xr is equal to xc, which means that xc is the location of the centroid in the x direction. So xc from this figure we know it is equal to 2 meters. So the location of the resultant force in the x direction is equal to 2 meters. In order to find the yr, we, we have to put the value of Ixc, which is equal to pi r raised to power 4 divided by 4, and yc is equal to 10 divided by sine 60, and we can find using the trigonometric rule. And area of the circular plate is equal to pi r square. So we can simply find yr, which is equal to 11.6 meters. This is the location of the resultant force in the y direction. The second part of this lecture is the hydrostatic force on the curved surface. So if you want to calculate the hydrostatic force which is acting on this curved surface BC, we need to understand two things. There is a horizontal force Fh, and there is the vertical force which is acting on this curved surface. The horizontal force is equal to the force which is acting on this plane AC, and the vertical force is equal to is the sum of the vertical force which is acting on this plane AB plus the weight of this semicircular half semicircular water, the weight of the half semicircular water. If we sum F1 and W, it is equal to the vertical force. And in order to calculate the magnitude of the resultant force, it is equal to Fh square plus Fv square root. So we'll move towards the first problem, and the problem says the 6 feet diameter drainage conduit is, as shown is in the figure, is half full of water at rest. Determine the magnitude and the line of action of the resultant force that the water exerts on a 1 feet length of the curved section BC of the conduit wall. So we know that the vertical force is equal to the weight of this water, and the horizontal force is equal to the force which is acting on this plane. So F1 is equal to the horizontal force is equal to gamma times hc times area. So gamma is the specific gravity, hc is equal to the height of the centroid, which is equal to 3 by 2 feet, and area is equal to 3 feet square. In order to find the horizontal force F1, it is equal to the specific gravity times the height of the centroid of the plane multiplied by the area of the plane. So the area of the plane is equal to AC multiplied by 1. AC is equal to 3 feet and 1 feet is the length of the curved section. So 3 feet multiplied by 1 feet is equal to the area, and the centroid of this rectangle is equal to 3 divided by 2, and you can find the horizontal force, which is equal to 281 pounds. So having found the horizontal force, we can find the vertical force using this formula. So as you can see, there is no water present above the plane AB. So the weight of the object is equal to specific gravity times the volume, and the there is no water present above AB, so the forces are zero above plane AB. So weight is equal to the vertical force is equal to just the weight of this water. So weight is equal to specific gravity times volume, and just put the volume and the specific gravity, you will find the vertical force, which is equal to 441 pounds, and you find the resultant force using this formula. So these are the two books which I am recommending you for further study. I've also mentioned some of the problems which you need to solve them. So thank you very much and good luck.